Hello, this is question 4 from paper 2 from the 2020 higher level maths Leaving Cert exam. Up the top right of the screen you'll find a card that will bring you to the playlist that has all my solutions for the questions in this paper. And below the video you'll find a link to an image of this question so you can try it in your own time before looking at my solution. This question is split into two parts. Part A and B, they're unrelated. Part A simply gives you this expression here and asks you to solve it. They do tell you theta needs to be between 0 and 4 pi. We'll look at that a little later, although I'll then show you how you could have looked at it now to help you out. So to solve it now, we simply take the inverse tan of both sides. The inverse tan will destroy this side and we'll be left with the inverse tangent of minus 1 over square root of 3. Make sure you're looking at radians at this point. They ask the question in radians. They tell us theta is between 0 and 4 pi. That means we're in radians. And it helps if you solve this in the calculator will give you theta over 2 is equal, I need to check my notes here, is equal to, at least my calculator tells me, is equal to minus pi over 6. I believe some calculators might give 5 over 6 pi as an answer. We'll see a little why now in a moment. Well, actually right now. We'll draw out the function, the tangent function. The tangent function here. At least we'll start at 0 and move on. You know, we'll do a little bit past there. There's minus 90 degrees or pi over 2. Yeah, let's start minus pi over 2. And this is just a generic tangent function. It's not this function. That's quite important to know. This is just a generic one. This is tan theta, not tan theta over 2. Okay, so this is just understanding what the calculator is. Well, the calculator is really my calculator only looks at this world here, starting from plus pi over 2 to minus pi over 2. Other calculators, I believe, look from 0 to 180 or to pi, 0 to pi. So there'd be pi, 2 pi, 3 pi, and 4 pi, although we're not going to need it up to this far. Right, so my calculator tells me the answer of minus 1 over square root of 3, which would be somewhere around here, minus 1 over square root of 3, gives me this answer here. Now I'm not actually interested, let me write this again. So it gives me the answer pi over 2 is equal minus pi over 6. And what I want to point out is there's more answers. There's other answers down here. So this goes on infinitely to the left, infinitely to the right. So get me this answer, but we need to know there's more answers. There's one here, there's one here, there's another here, another, and this is going on in both directions. So while they give us this answer, we do need to know that there's more answers. Let me rub this out right here. Minus pi over 6 is one answer. We need to realize there's another answer. There's 7 over 6 pi, or sorry, minus 7 over 6. That's pi this direction. Every pi this repeats. Pi distance this repeats, or 180 degrees if you rather that world. Every 180 it repeats. So if I take pi away from this, I'd get another answer. If I add pi on, and here's the one my calculator would give me, other people's calculators might give them this one, it would give you this answer. Or another one would be, I'm just going to add 6 onto this number every time. 11 pi over 6, 17 pi over 6, and this will stay going on forever. I won't bother writing too many of them. Okay, now we need to realize we're not looking for theta over 2, we're actually looking for theta. But there's multiple answers here. Let's just multiply them all by 2. So we'd get minus 7 over 3. Multiply this by 2, it's like dividing the bottom by 2. 7 over 3 minus pi over 3. I'll just write another couple, 5 over 3. And let's see, I'll write all of these. 11 over 3 and 17 over 3. And this is going on forever in both directions as well. Now is where we use the information they gave us at the start. They told me that theta needs to be bigger than 0. Let's see, bigger than or equal to? Yes, bigger than or equal to 0 and less than or equal to 4 pi. So let's see what we have. Bigger than 0? Nope. Bigger than 0? No. Bigger than 0? Yes. Smaller than 4 pi? Yes, that's fine. That's something like 2, just less than 2 pi's. That's okay. 3 goes into 11, just less than 4 times. So yes, this is good. This one's good. This one's good. Let's see. 3 goes into 17. 5 and 2/3. 5 and 2/3 is bigger than 4. So no, this one's out. And so will every other one be down that line. So there are our 2 answers. Our 2 answers would be 5 over 3 pi and theta equals or theta equals 11 over 3 pi. Now you could have done this slightly different, I guess. At the start you could have asked yourself, if theta is between these 2 numbers, well then theta over 2, multiply them both by 2, or divide them both by 2 I should say, is between 2 pi and 0 and 2 pi. So that means we would only need to, this function here, we did it on theta over 2. So let's see, we could call this theta over 2, and it would mean we'd only have to look in this world here. So I could rub out all this. I could rub out the bit before here. We could ask ourselves, where are we looking when we begin the question? I think that's probably more useful. Even though I did it another way, I think it's probably more useful to think of what world you're looking in at the start. You'd have to think it through and realize there would be an answer here and an answer here. My calculator would still give me this answer down here. So I would still need to know from this answer, I need to add on 2 pi. Now 2 pi, it's because we're actually doing theta over 2. That's why I didn't do it this way. It becomes a little confusing because I'd like students to become used to cosine, sine, tangent rules when they look normal. So I tend to try and draw them as normal all the time. Whereas in this case, we're not in x world, we're in theta over 2 world. So this isn't necessarily, actually in this world I guess I'm adding on pi each time. But I've changed the basis. So it gets a little bit confusing, at least for me. So maybe you're much better at doing it this way. You'd get the same answers each time. You would get theta over 2 is equal, same thing we got. Or if you wanted to change that to theta, you would have to go ahead and change this to 2 theta and 4 theta would be another way to do it. Either way, these are the 2 answers you should get. I think I've probably just confused myself and you guys with my second explanation there. So maybe just ignore that or ask me some follow-up questions in the comments below. Okay, I'm going to rub this out and we'll move on to part 2, or B. Okay, part B gives us this drawing here, and they ask us to find the length of BC. That is the length of this here. Now, the first thing I'm going to do is I'm going to show you the wrong way to do this, a mistake that a lot of students, I'm guessing, are going to make. Now, if you've come to this video, maybe you've got the wrong answer somewhere, and you're like, where did I go wrong? What's wrong with this? So maybe you did it this way as well. I want to point out something. A lot of students might have rightly noticed that the length of this here is 7. Let's move this 7 down so that's a bit clearer. This is 7, and we're looking for this. So that means we're really just trying to find this length here. And then what I think some students may have done is drawing this triangle, 1.2. Make sure your calculator's in radians. I hope that's probably the most common mistake students would have made. So that's in radians, that's 7. And I think a lot of students might have just put a right angle there. Because now it's simple, it's a simple matter of taking the cosine of 1.2 is equal to, let's call this x down here, is equal to x divided by 7. Therefore, x is equal to 7 cosine 1.2. And you're finished. You have this length. 7 minus this length will give you this length. It'll look right. It'll look roughly okay. It's probably even very close to the correct answer if you have the correct answer, but it's wrong. And the mistake is this is not the right angle. Or at least they never told us it is. Maybe it is. In fact, the answer tells us it's not if we work it out. But that's not a right angle. They made it look like it. Now, it's rare for them to do this, but they're trying to trick you there. They're trying to give you a question that looks like something that's not. And in fairness to them, this happens in real life a lot. You shouldn't make an assumption like that. If they didn't tell you that's a right angle, maybe it's 89 degrees, maybe it's 91 degrees. We can't assume it. So that's the mistake made. Now you should have had a clue that, that was too easy. I never used the 21. I finished really quick. This doesn't seem right. So that should have been your clue. Let's look at another way to do it. We need to use the fact of this area here. And how to do that is we need to look at three shapes. The three shapes are a segment of a circle, the large bit, that's 1.2 there, that's 7, that's 7. We need to look at this triangle that looks like a right angle, that's not, 1.2 and 7. We'll keep this calling this X that I called a minute ago. And then the final answer, and this is that's too pronounced. We'll draw something like this. Looks like part of a circle, but it's not. This length is much shorter than this length. But we do know it's 21 degrees. It's 21 centimeters squared. So let's make the areas all equal to each other. This big shape, take away this shape, should equal this shape. That's where the secret of this question comes. And we often do this in maths, even in higher level. We just take shapes away. That's all we're doing. We're cutting this big shape, we're taking this one away from it, and we're left with this shape. And the areas should all equal. The area of this will be 21. The area of a segment of a circle, it's in our formula tables, it's a half the radius squared, in this case it's 7 squared, multiplied by the angle. Not the sine of the angle or anything, just the angle. That's because we're in radians. That's why we love radians as mathematicians. We don't have to use sine here or anything like that. This is a triangle now. This is we do have to use sine to get this. You can work out the area of it on your own if you want by using sine rules, cosine rules, sine rules, but to get the perpendicular height here. But there's a formula in our book, so we'll just use that formula. That is a half times the two sides. So A and B it says, but really any two sides you want. In this case 7 and x. Multiplied then by sine of the angle between the two sides. So really any triangle can be done if you know these three things. A, B and big C in there. So that would be sine 1.2. And this should equal 21. And if we look at this, there's only one thing unknown here. The only thing I don't know is x, so I just have to rearrange this. Now you can do this as carefully as you want, take as many lines as you want. I have a bit of practice, so I'm going to do it a bit quicker. I'll just take x out here. What's going to be left? 21 will be, nothing will have happened 21, so he'll be there. We'll have to take this away the other side. So that's minus, let's say that'll be 49, that's 7 squared, divided by 2, multiplied by 1.2. Right, and then we're going to have to divide by these guys that are multiplying the x. So we'll have to divide by 7 over 2, and we'll have to divide by sine 1.2. There's the 7 over 2, 7 multiplied by half. And this bottom row should be a minus, or you put the minus anyway. Put the minus here in the bottom, or both of these spots. So that could be a minus now as a plus. But that'll work. All you need to do is put that into a calculator. I'll just get that from my notes, but also let me double check I have all these things right here. 21 minus 7 squared over 2, yes, multiplied by 1.2. Bottom row is divided by minus 7 over 2, sine 1.2. Yeah, that all looks good. If we put that into a calculator, you should get, I'm writing the final answer down. We should get 2.575. That's this length here. Remember, we're looking for this length. So the final answer, what is that called? That's called BC. The final answer, BC, is equal to 7 minus this guy here. But they only wanted 2. I get three decimal places here. They only wanted 1. So our final answer would be 4.4. And that's, you might as well put in the units as centimeters. Okay, I don't think you'll lose it. Yeah, you don't lose any marks in the maths papers for these, at least as far as I know. But still, if you know the units, put them in. Okay, I think that answers everything. If you have any follow-up questions, see any mistakes I made, anything like that, don't be afraid to put it in the comments below. I will check if I'm wrong, if you're wrong. We'll find the right answer, we'll talk it through, we'll all get smarter from it. At least that's the hope. So thank you for watching and have a great day.